Hi guys, welcome to Mature Chemistry. So, in today's video, I will be showing you how to distill crude ethanol using a simple homemade still, and later I will try to concentrate it using some lab equipment. Ethanol is very useful not only in culinary, but also in chemistry, where it needs to be as clean as possible, because some reactions require very pure ethanol, and that is the reason why you would want to distill it. Here I have some dirty ethanol that I used in my caffeine extraction video, and I really don't want to throw it out, so I decided to recover it, and to do that, I first need to assemble my distillation apparatus. I could of course just use my lab distillation setup, but since distilling the ethanol is very easy, I decided to build my apparatus from scratch to show you that you can also build one yourself from the materials that you find around the house. Before I start the build, I will quickly show you how a distillation setup works, because if you know that, then you can design your one from scratch. The basic idea behind distillation is that you take a few things with different boiling points that you want to separate and evaporate them one at a time, while also condensing and collecting their vapors. This essentially allows you to purify a lot of different mixtures, because when the solvent is distilled over, all of the impurities remain behind, and that behavior is insanely useful for a ton of things in chemistry. Every distillation apparatus consists of three main components. The first is the boiling flask, where the impure mixture is heated. The second is the condenser, which turns the vaporized solvents back into the liquid state. And the third is the collection flask, where the condensed distillate is collected. Almost every distillation apparatus will work if it has these components well assembled, and now I will try to build one from very simple materials. For my boiling flask, I went with a jar with a hole in its top placed on an electric stove. Then, to make the condenser, I cut a plastic water bottle like this and placed it on the top of another jar, which will serve as the collection flask. After that, I connected everything with a piece of latex tubing, and the setup was almost ready. For the final step, I got some water with ice and added some salt to lower the ice melting point. Then I poured this mixture into a condenser while making sure that it won't leak into the collection flask. It will serve as the coolant to condense any vapors passing by the latex tube. To get this setup running, I poured my dirty ethanol into the boiling flask, sealed it, and turned on the heating. After a few minutes of heating, the mixture started to gently boil and some vapor started condensing in the boiling jar. Ethanols and water's condensed vapors look different, and it is pretty easy to distinguish them. Here we have an example. After a few minutes of boiling, the ethanol vapor started to come over the latex tube and condense in the ice-cooled condenser. The rate of distillation was really slow, so to increase it, I turned up the heating and let the mixture boil more vigorously. At the cost of the speed increase, more water will start coming over along with the ethanol. Here it isn't a problem, because I don't want to concentrate the ethanol, but just to remove the impurities. While the ethanol was distilled, I had to replace the coolant a couple of times to make sure that all of the vapors will condense. Also, near the end of the distillation, the latex tube turned white and the boiling ethanol was starting to turn yellow. I guess that the ethanol is leaching out some of the chemicals in the tube and destroying it in the process. In another run, I will probably use a tube made out of a different material, but for now, the latex one will do. When most of the ethanol was distilled over, I noticed that the mixture in the boiling flask became thicker, which indicated that there was some kind of impurity present. This was a good time to stop the distillation, and after turning off the heat, I started to disassemble the apparatus, and even my cat came to help me. In the end, I was left with a nice amount of the distillate and some yellow mixture that I had to put away for now. The distilled ethanol was still cloudy due to the impurities from the tube, and to fix that, I set up a quick gravity filtration and filtered it. When it was filtering, I randomly decided to check on my yellow mixture, and surprisingly, it turns out that some white crystals have appeared in it. It was just some caffeine left over from the caffeine video, and just for fun, I decided to recover it. In the end, I didn't get much, but I did it mostly to show you why distillation is so useful. Anyway, now I came back to the ethanol, which was now much clearer, but still, I wanted to make it better. It probably still had a ton of water left in it, so I decided to try and concentrate it using some lab distillation apparatus. It will allow me to control the temperature better and thus separate the ethanol, which has a boiling point of about 78 degrees Celsius. The separation still probably wouldn't be perfect, since I don't have a separatory column, but I wanted to see how far I can get. After assembling the distillation apparatus, I turned on the flow of water and filled the flask with the distilled ethanol. After that, I slowly raised the temperature to not allow it to go past 100 degrees, which is the boiling point of water. After some time, the ethanol started distilling over and it was slowly collecting in a flask. At some point, I turned the temperature up because the distillation was going very slow, and that of course resulted in some unwanted water coming over. After a few hours, the smell of ethanol was gone and the condensing vapors looked different, so I turned off the heat and let everything cool down. When the setup was at room temperature, I disassembled it, and as you can see, I managed to get a lot of the impurities and water out of the ethanol. I still wanted to know what was its concentration, and to check it, I weighted 100 ml of my distillate. In theory, the maximum that I could get was around 95%, since it is the point where the ethanol forms an azeotrope with water. But in reality, after checking the concentration in a chart, it was bad to say the least. After all of this effort, I was kind of sad because I expected to get at least 50% pure ethanol. I know that if I were more patient and had a separately column, I could achieve much higher purity, but oh well, maybe I will do that in the future. To cheer myself up, I mixed my ethanol with some lithium chloride to make a pretty pink flame. One advantage of my ethanol is that it is completely free of any sodium ions, meaning that it can give off very clean flame colors. Here you can see me mix it with some boric acid, and after ignited, it gives off a very nice and clear green flame. Anyway, that is all that I wanted to show you today. If you enjoyed this video, you can consider liking it and subscribing to my channel. See you in the next one.